Everyone, how's it going? Hope you found the lessons on area of a triangle, area of a parallelogram, area of a square, and rectangle rather straightforward and easy. We are now going to kind of put everything together and talk about how to find area of a trapezoid. So as you know, a trapezoid is a quadrilateral. Um, Trapezoids have a pair of parallel sides known as the bases and a pair of non-parallel sides. We're going to talk about how to find the area of a trapezoid, and that also means then this will work for an isosceles trapezoid. So there's two ways we focus on finding the area of a trapezoid. If it's pretty straightforward, you can use a formula to find the area of a trapezoid. And that formula would be taking the two bases, adding them together, multiplying it by the height, and then dividing it by 2. So if you want to use the formula, you do need to have the information for base 1 and base 2, as well as the height. Now, adding the bases, multiplying it by the height, and dividing it by 2 is the same as taking 1/2 the sum of the bases times the height. Similar to like when we talked about the triangle, you could do 1/2 base times height or base times height divided by 2. Okay. The second way we can calculate the area of a trapezoid that you might find a little easier is known as dissection. And when we talk about dissection in terms of any sort of polygon, really we're just talking about breaking up the figure into familiar polygons. So like for a trapezoid, we would think about breaking up our trapezoid into a rectangle with maybe a triangle or multiple triangles. And then we know the area of a rectangle is base times height, the area of a triangle is base times height divided by 2. Right? So these are the two main ways that we calculate the area. You kind of can fill out the diagram and decide, oh, maybe the formula is easier. I can figure out the base and the height. Maybe you feel like breaking it apart into a rectangle with a triangle or multiple triangles is easier for you. So we're just going to walk through the example that we had on your worksheet and see how it works. We're going to do it both using the area and also by dissection. So if you take a look at what we have here, this is very similar to when we first talked about a trapezoid in class. And especially in an isosceles trapezoid, we said for an isosceles trapezoid, you have your bases, and then you have your non-parallel sides, which are always going to be equal. And what we discussed doing in those cases was dropping down 2 altitudes from the top base, forming then 2 equal right triangles. And we did that in terms of now being able to deal with that we have a rectangle in the middle and 2 equal right triangles on the left and the right. So with that being said, we know if this length is 6 centimeters here, that this length on the bottom is also 6 centimeters. And we know, well, if this is 6 centimeters and the whole thing is 12, well, then that leaves 6 to split between this piece and this piece. So half of 6 is 3 and 3. Okay. Well, we need to do that to find the height of this trapezoid, because if we want to use the formula, we have our bases at 6 and 12, but we don't have our height. The height is missing, but the height is actually the height of this triangle off to the left over here, or the height of this triangle off to the right over here. Really doesn't make difference which one we look at because they're congruent, they're equal. So with all that being said, to find the missing height or the missing side of that right triangle, we're going to use Pythagorean theorem. Remember, Pythagorean theorem is a squared plus b squared equals c squared, where c is your hypotenuse. So if this is my right angle, over here, my hypotenuse would be 5. I have this base of 3 in my triangle, and then the height is what I'm looking for. I'll leave that as h. All right, so we would square 3, square 5, so we get 9 and 25. Do some quick algebra there, and we get h squared equals 16 after subtracting the 9 from the 25. Take the square root of both sides, and now we have h equals 4. So quickly we find now that our height is 4, our one base is 6, our other base is 12, and we can substitute it right into our equation or formula. 1/2 base 1 plus base 2 times height, or base 1 plus base 2 times height divided by 2. And so I did that, and I found out the area is 36 centimeters squared. Okay, so that's using the formula. Now again, it wasn't exactly straightforward in terms of just taking the number straight from the diagram. We had to do the extra step here of finding the height using Pythagorean theorem. Now, if we want to use dissection and break apart this figure, so that's on the second page of that handout, you still need to work to find the height of the trapezoid. So using Pythagorean theorem isn't going to go away. You're going to have to do that because without the height, you can't find the area of the rectangle or the triangle. So dissection, first step would be, okay, let's find the height of the triangle. We found it to be 4. Now the second part is a little different. We're going to focus on having this here rectangle. And I'm going to actually go back and just quickly erase this for a second so I can highlight here what we have. Okay, so now we know that right here is 4. Okay. All right, so now we have 4 here. So our rectangle, we need a base and a height. So I'm going to go over here. Let's see, here's the base. Here's the height. So it's 6 times 4. Okay, so area rectangle, 6 times 4. Excellent. 24. Now the triangles, there's 2 of them. So let's focus on the triangle. Well, the triangle is over here on the left-hand side. Okay, height is 4. Base is this tiny piece, which is 3. So let's focus now over here. The triangle has a base of 3, height of 4 divided by 2. So 3 times 4 is 12, divided by 2 is 6. Okay, so now that we have the area of the rectangle and the area of each of the triangles, we're going to add everything together. So area of the rectangle at 24, area of the first triangle at 6, area of that other triangle, which is congruent to the first one, is also 6. The sum of all 3 numbers is, again, 36 centimeters squared. Okay, so same answer, obviously, 2 different methods. One is a little bit longer, I would say, in terms of having to know multiple formulas. If you're using dissection, but really I think that they're both valuable in their own different ways. Okay, at the end I left a little note here. You choose what works best for you. Depending on what information is given, you may think that one is easier than the other, and by all means you do whatever you see fit. Okay, so now what we're going to do is just practice. I'm going to kind of walk through some practice problems, and let me just change my view here and see what we do. Okay, so here is your first example. I had asked you to determine the area and the perimeter to the nearest hundredth of the following trapezoid. So first, let's just deal with the area. So here's our area with our formula, base 1 plus base 2 times the height divided by 2. All right, so I took a look here. It was pretty obvious. My bases were 8 and 3. My height at 7. Perfect. Substitute in everything. I have 11 times 7, which is 77, divided by 2 gives us 38.5 centimeters squared. Again, remember, area is squared because we're talking about more than one dimension. Okay, then the perimeter. So it's a quadrilateral, meaning we have to add 4 sides. If we take a look at what we have here, we only have 1, 2, 3 sides. We're actually missing this 4th side that I labeled X. So now to find that missing side in order to complete the perimeter, look here to see what I did. I actually formed an altitude and created this right triangle off to the left and then a rectangle over here. Now since this is a rectangle, I know that if this is 3, so is this distance down here. That means that this tiny piece over here is going to be 8 minus 3, because the whole thing is 8, this piece is 3, and the remainder then is 5. So now what I have is this triangle, which I have drawn over here, right? And I have a height of 7, base of 5, hypotenuse is unknown. So what am I going to use? Well, there it is again, Pythagorean theorem. Love that good old a squared plus b squared equals c squared. I have our hypotenuse, which is x, put that in for c. Our 2 legs, a and b. Remember, order doesn't matter, addition is commutative. Square 5, square 7, add them up, we get 74 equals x squared. Take the square root, and x is approximately, now remember, it says the nearest hundredth up here. Hundredth is 2 decimal places out. I don't round until the very end, so I'm going to round this to approximately 8.6023. All right, so that had my approximation. That's what the squiggly lines mean, the squiggly equal sign. My perimeter would be that missing side at 8.6023 plus 3 plus 7 plus 8 to give us a total of approximately 26.6023, which again, nearest hundredth, the 2 tells the 0 to stay. So we have approximately 26.60 centimeters as our perimeter. Okay, so hopefully you're starting to see a pattern here of what's happening, right? Even though we have a trapezoid, we are referring back to triangles and rectangles. We're using Pythagorean theorem. Lots of previous knowledge is being tied in here. Let's take a look at the second one that we have. And here it is. Okay, so another question where we're asked to determine the area in the perimeter. Let's just take a look at our diagram here. If I take a look at what's given, it looks like they're giving me one base at 12 centimeters, one base at 24 centimeters, one leg at 10 centimeters, but then because of these tick marks, I also know that this leg is 10 centimeters. So in terms of perimeter, I'm just going to think about that first. I have one, 2, 3, all four sides. So right off the bat, the perimeter is pretty straightforward. It's 10 plus 12 plus 10 plus 24, 56. So perimeter is 56 centimeters. I like it. It's done. And you know what? Even though it acts as the area first, why not find the perimeter first? Half the question is now out of the way. Okay, so now let's figure out for area. What do we know? Well, we know here we need base 1. So base 1, base 2, doesn't matter if it's top or bottom, but here's our one base at the bottom, 24. Here's our other base up here at 12. Okay, so our bases are taken care of. And once again, the height is missing. So typically, when your height is missing, it is going to require, in a trapezoid, if the height is missing, using Pythagorean theorem in some way. So what do? Well, back to basics. We know if we drop down our altitudes, then this part of the rectangle is equal to its opposite side, which is 12, right? So now this whole base is 24, and of the whole base, 12 centimeters is taken up by the rectangle. So 24 minus 12 gives us now 12 centimeters to split between our two equal right triangles, which now tells us each of the bases of these triangles must be 6. So that's how we're getting 6 and 6 here and here. Okay, so now since I have that, I'm going to go back and erase one more time. Just focus on our little triangle. And here it is. Focus on my triangle. My right triangle, I should say. So I have it drawn over here, my right triangle. I am using my Pythagorean theorem. I only really need to find C in terms of placement. C is our hypotenuse opposite the right angle. It's right here by itself, 10 squared. And then I just substitute in my 6 and my H for A and B. Do my algebra, and I'm finding that at the very end, H, my height is 8 centimeters. So I'm going to substitute that in up here. Awesome. Once that's done, I have now everything I need to plug it in. My base 1, base 2, and my height. Take the sum, divide it by 2, and our area comes out to be a total of 144 centimeters squared. Okay, so yes, these problems require just a tad bit of work, but really basics are perimeter. You know how to find perimeter by adding the sides. Area, a formula is there, right? We know we need a formula. It's just a matter of finding all the information, and applying Pythagorean theorem is something that we should be able to do. It's just looking at a right triangle, finding the hypotenuse, and based on trig and lots of our practice, finding the hypotenuse should almost be like second nature now. It's always the longest side, the side opposite the right angle. Okay, so that was the second question. Now, speaking of trig, we had number 3. And I know this is probably a tad bit maybe challenging, or you look at this and you're like, oh man, trigonometry, really, Miss M? You're going to throw that at us? And yeah, we have to. But what we're going to do is just take this like step by step and see what's happening here. So we need to find the area of this trapezoid. So take a look at what happens. we have this diagram, and all they're giving us is this angle down here at 60 degrees, this side at 8, which we then know means that this side is 8, and this one base at 12. So based off of that, if I'm dealing with area, this formula, right, base 1, base 2, height, I have one of my bases. I don't have my second base, right, this base along the bottom, that's missing. And I don't have my height, that's also missing. So how do we figure out the height and the base on the bottom? And what we're going to do is we're going to use 60 degrees as our reference angle and apply trigonometry. So this is how I saw to do it. And maybe you want to take a different approach, that's fine, as long as we're ending at the same result. If you want to just email me and see, hey, Miss M, this makes sense too, I can certainly take a look and kind of give you my advice and help you out from there. So if you take a look at what we have here, I redrew our triangle down here, our right triangle. And I first started by trying to find the height. So I placed an H at the height. And I use this as my reference angle. And I know opposite the right angle is the hypotenuse. Opposite the reference angle is my opposite side. So with O and H, that's the S, or the SO in SOHCAHTOA, which is sine. So I have my reference angle is theta. I have the side opposite is H, and I have my hypotenuse is 8. I'm just substituting everything into my sine of theta equals opposite of hypotenuse. Now, since I'm looking for a side, I create a proportion, so I put this over 1, and I would just cross multiply. Now, this is a nice one, because H times 1 is just H, so H is by itself. And then we always take our denominator, 8, and multiply it times the sine of 60. Put this right into your calculator. You make sure you're in the right mode. And you get approximately, and let's see what they want to round to, nearest tenth. So I'm going to round a couple of decimal places past that. So H is approximately 6.9282 centimeters. So once I find my height, I put that right here, height. Okay, so really not so bad. Nice simple trig to find the height. Now, dealing with the base, because I have to find base 2. And if you notice, base 2 says 20, but I don't have anything over here that says 20. What we did was we took a look and we said, well, if these are two equal right triangles, that means that this piece and this piece are equal. So if I again focus on having a right triangle, I can do trig again, and I can say, okay, well, I have the hypotenuse, this is my reference angle, and now this side is adjacent. So look over here. Just change it up a little bit. I said, okay, here's my reference angle, here's my adjacent side, here's my hypotenuse. So now A and H is the or cosine. So once again, cosine of our reference angle, which is 60, equals adjacent, which is the A, x over hypotenuse, 8. Put this over 1, cross multiply, and again, we're lucky because it's 8 times the cosine of 60, and x times 1 is just x. And this approximates to 4. So now we know the base for the bottom is approximately 4, 4, and 12. We have to add all three of these together to get a total of 20. So there it is, base 2, 20. Add everything up, or I should say, put everything together into our formula. Base 1 plus base 2 times the height divided by 2 gives us an area. Rounded is approximately 110.9 centimeters squared. Okay, so again, definitely a lot to kind of digest here and to follow along. But what we did was, instead of using Pythagorean theorem, which, why couldn't we use Pythagorean theorem? And if you think about why we couldn't, in the way beginning, with nothing given other than this 8 centimeters here, we have 2 missing sides of the right triangle. So Pythagorean theorem wouldn't have worked to find the height initially. You technically could have used Pythagorean theorem to find the x over here, this little base of this triangle if you wanted to. I just like to stick with, if I'm going to do trig, I'm going to follow through with trig. I personally find trig a little bit easier in terms of just, okay, it's SOHCAHTOA. Label my sides, plug it in, cross multiply, and figure it out. But again, another question, done. Okay. Now we had our last question, and here it is, number 4. So what we have here is we have a piece of land that's in the shape of a trapezoid. They're telling us that the area of that triangle is 600 square feet. We have to find the minimum number of feet of fencing needed to completely enclose the entire parcel of land. Piece, parcel means piece of land. Okay, so now here's the thing. They mention area of a triangle, and then they're talking about fencing, fence. So when you think of fencing, and then they're also talking about area, it's kind of contradicting itself, right? Now, here's the thing. They're saying this piece right here, they're giving you the area, but they want to know what's the fencing needing. What's the perimeter, right? We have to figure out perimeter here. So we're going to have to find the perimeter of the trapezoid. So in order to find the perimeter, we first need to figure out, well, perimeter, if I just go ahead and I say, okay, I have to find this. Oh, that's easy. It's 70. This, oh, that's easy. That's 40. This, not so easy because this is missing and also this is missing, right? So take a look at how I started here. I said, well, if this is 40, then this is also 40 over here because it's a rectangle and opposite sides are equal. And then I actually took a look and I said, well, off to the right over here, what we have is this nice triangle, and it's a right triangle. And what I know about this right triangle so far is that the height is 40 and the area is 600 feet squared. So with that being said, take a look. Here's what I know. The area is 600 square feet. So my area is 600. My height is 40. The base is missing. I'm going to let that be x. So I substituted in everything I knew, and I created this over here. So take a look. I have my area, my missing base, my height at 40, and then part of the equation, a formula is to divide it by 2. So what do I have? I cross multiply. So 600 times 2 is 1200. X times 40, well, that's just 40x times 1. Well, that's just 40x still. So now I have 1200 equals 40x. I divide by 40 and I have x is 30. So now I know that the base over here in my triangle, this x piece, is 30. Well, it's helpful because now this entire side, let me see if I can do this, is from here all the way to here, is 70 plus 30, which is 100. Okay, don't mind my handwriting. I know it's a little messy. Just trying to get used to using the mouse to write. Okay, so back to what we need. So now we have that this is 40, this is 30, and I'm missing this side. Well, it's a right triangle. I have 2 sides. I'm missing a third. We can't use trig, right, because there's no reference angle. What we're going to use is, yep, you got it, Pythagorean theorem. So what I did was I redrew it over here. Here's our 30. Here's our 40. Here's our missing side y. Let's make this like a better triangle. So we have our hypotenuse. Our C value is y. 30 and 40, A and B. Substitute in everything. And you might notice that this looks very similar. Do you guys remember right triangle, a 3, 4, 5 triple? So if it's 30, 40, this would then have to be, yep, 50. Or just use Pythagorean theorem. Take a look at the algebra. We find that y is 50. So now, back up here, we have our 50. So we have our 1, 2, 3, 4 sides. So to find the perimeter, let's scroll down. We have this side here, which encompasses the 70 and the 30 feet. This side, which encompasses 40, go across at 70, and we go diagonal at 50. Everything up, and the amount of fencing needed is 260 feet. It's not squared because, again, this is perimeter. Perimeter is one-dimensional. Area would then be squared. Okay? So that wraps up really everything that we're going to talk about in terms of a trapezoid. Um, Personally, I like the trapezoid. I think it's kind of cool because we're talking about rectangles and triangles, and we're dealing with Pythagorean theorem and trigonometry. Um, it's nice that a shape, I mean, for me, I find it nice that a shape seems so simple, but really can be so complex. Um, so this again was area of a trapezoid. I hope you guys were able to follow along. Remember, if you have any questions, reach out. Feel free to click that little envelope on my e-board page, and it'll bring you right to an email directed towards me, and I can help you in any way that I can. I hope you all are all finding these lessons helpful. Please, feedback is really important to me. I'm teaching to a screen, so I'm used to seeing you guys, and although sometimes you might be a little asleep and just staring at me, it's better than now just looking at my screen. So I appreciate the feedback. If you just let me know, is this working? Am I going too fast? Is it too much work? Let us know how we can better tailor the lessons to meet your needs. All right, take care. Talk to you later. Bye.